So hopefully you've had a look at the slides that I've put on for you to look through. You've made some notes. It's really important that you're making those notes, not just looking at them. If you can't print them off, that's absolutely fine. You can just write down the key points. And it's really important now that as I go through this example, you're writing this example down so you've got it to refer back to. So the first example is about the alkalinity in milligrams per litre, which I can't spell as always, of water in the upper reaches of rivers in a particular region is known to be normally distributed with a standard deviation of 10. That's really important. Hopefully you've already seen this question when we've looked at calculating test statistics earlier on in the lesson. You should notice this is the same question, but rather than just being asked to work out the test statistic, we're being asked to do the hypothesis test. So the upper reaches of the river have a standard deviation of 10, and the lower reaches of the river have a standard deviation of 25. And then we've got our two samples. We've got 10 readings from the upper reaches and 15 readings from the lower reaches, and there is our information. It says investigate at the 1% level of significance the claim that the mean alkalinity of the water in the lower reaches is greater than that of the upper reaches. That bit's important because it tells us our hypothesis. Now I have printed off the blue boxes, although they are in black and white. If you can, I would use them. They're really helpful while we're practicing, while we're learning. If you haven't got a printer, it doesn't matter. You can just write the answers on paper. People have been doing them on paper and they've been getting really good marks. Okay, so they're not essential. So the first thing we have to do is we have to state our variables. Again, you're getting good at this. You're getting good at telling me what the variables are. So in this question, we are looking at the alkalinity in milligrams per litre. So that is what X is going to be. So let X be the alkalinity in milligrams per litre of water in the river. Now my H0 and my H1 are slightly different. I am no longer looking at the population mean being equal to a value. I'm looking at two population means being equal to one another. So I have mu A equals mu B. Now just for clarification, to make sure I get that mark, I'm just going to let the examiner know that A is the upper reaches and B is the lower reaches. I'm just telling the examiner I know what we're talking about in this question. That's my context. Then the bit we highlighted at the end said that we're investigating that the lower reaches is greater than the upper reaches. So that needs to be my hypothesis, is that my lower needs to be greater than my upper, so it needs to be that way round. Now, as with all the other hypothesis tests we've been doing, that makes it a one-tailed test because it's a less than question. We're only looking at the left hand side, and it also tells me in the question it is a 1% significance level. That's obviously really important because it's not the usual 5%. Now, slightly different to before, and for some reason I've missed a bit off that I've noticed while I'm starting doing this, is I no longer have just a sample mean, I have two sample means. I've got the sample of my upper reaches and the sample of my lower reaches. Now if you've already done task 1, which you should have done, you will already have found these values out, but just in case you haven't, I'll do it for you. So my upper reaches, I have 91, 75, 91, 88, 94, 63, 86, 77, 71 and 69. I add those together and then I divide by how many I've got, which is 10, which it does tell me in the question, and that gives me a sample mean of 80.5. So that is my X bar A, 80.5. For my x bar b, I do the same for the lower reaches. So on my calculator I do 86, 95, 135, 121, 68, 64, 113, 108, 79, 62, 143, 108, 121, 85 and 97. I add those up and I divide by how many I've got, which should be 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 it is. And that gives me a mean of 99. So that is my sample mean B. Now the mu, I've left it on here because I want to try and keep these blue box sheets as similar as possible. But the mu for this is unknown, and it will always be unknown in these questions, and that's fine, that's important, we don't really need that. What I should have done, and I haven't done here, is I should have split this box, as I've done this one, into sigma A, sigma squared A. I'll make sure your boxes are sigma squared A and sigma squared B. And they don't look like this, I'll make sure those are done properly. And those are my population means. So this is for known standard deviations or known variances. And it's important as well, the formula uses variance, so we need to use variance in our calculations. So it tells me earlier in the question that the standard deviation for the upper regions was 10. So my variance is 10 squared or 100. And the standard deviation for the lower regions is 25. So my variance is 25 squared, or I believe that is 625. And again, I'll make sure yours is done properly. This should be NA and NB, because I've got two samples. And that is 10 values in the sample for the upper region. Oh, move that across, sorry. And 15 samples. 15 in the sample for the lower region. So I've just been filling in those boxes. Then my critical values. I'm going back to my trusty table 4. This is a one-tailed 1%, so I should be looking up 0.99. If I look up those values down here, I get 2.3263. And because this is a less than question, I'm looking at the lower tail, so that makes it negative 2.3263. Now my test statistic is what we were practicing on task 1 before we got to this part, so I'm not going to spend too long on this, but just make sure we're doing this correctly. Our test statistic is x bar, remember this formula is in the formula booklet, minus y bar, take away mu A, take away mu B, all over, and then we have the square root of, which I'll put on afterwards, sigma squared A over NA plus sigma squared B over NB, and that is square rooted on the bottom. What people often forget here is they put 10 and 25 instead of 10 squared and 25 squared, which is why that's important, that a little bit higher up. Now please watch how I put this on my calculator, because this is where some of you are slipping up. I'll make sure it's not in the shadow. Okay, so I press my fraction button. I type in the top of my fraction 80.5, bracket, 80.5 minus 99 bracket, take away. Now if H0 is true and mu A and B are equal to one another, then mu A take away mu B, if I can get that out of the light, there we go, is 0. And then I go to the bottom of the fraction and I press my square root fraction. So I'll do that again. So I do take away 0, I go down to the bottom of the fraction, I press square root fraction, and then I do 10 squared over 10, add, and then fraction again, 25 squared over 15. Then I go to the end of my fraction and I press equals. Check you can get that answer. If you can't get that answer, you get a different one, you need to go back and try it again. So you should be getting for that answer negative 2.573, and then if I round it, 8. Okay, please check you're getting that. Now, my compare, I'm loving your normal distributions. They're really good, really accurate, and getting you the right answers just shows how important it is to draw those normal distributions. So draw my normal distribution. I'm going to put on my negative 2.3263. Draw that off. I'm going to look at this value here, negative 2.5738, and I'm going to say that's all the way over here. I accept in the belly, I reject in the tail, and my value is in the tail. So hence we reject H0. What was H0? H0 said that my two means were the same. It said that the distributions were, the population means, sorry, were equal. We are rejecting that. We're saying that that is not true. So I need to put that into context. Therefore, there is significant evidence to suggest. And what were they asking for? What did they ask me to look for? They asked me to look if the alkalinity of the water in the lower reaches of the river is greater than that of the upper reaches. Put that in your answer. Significant evidence to suggest that the alkalinity of water in the lower reaches, I can't spell at all, of the river is greater. Running out of space, the upper reaches. And that there is a completed example. Like I say, for the blue boxes, I'll make sure these are corrected and those are split for you. That's what you are looking at. I'm going to be marking these as I have been, with a lot more marks than the examiner. So I'm going to be doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we're doing 13 marks. In an exam, these would be between 8 and 12. Okay, depend on how much they're asking you to do. I'm going to be doing 13 marks. That is what I'm looking for. I'm just going to zoom that out a little bit if I can, so you can see the whole answer. Okay.